Hello everyone, so this is a recording of the Eviews exercise problems which we should have done this Wednesday at the end of September, so that's the 28th of September, but the class was cancelled. So we're going to deal with dummy variable exercises. If you go to chapter 7 of the main text and look up the exercises in it, the first one, C01, is an exercise which refers to college GPA and computer ownership, but will also add variables of mother and father college variable, so MOTH call and FATH call, and it refers to an equation which is estimated in equation 7.6 in the main text. So 7.6 in the main text is just this equation that I already typed in here. So I run it, and this is a regression which estimates the predictability of college GPA, or the effect on college GPA of a number of variables. The first one is the computer ownership, so the PC ownership. As you can see, the PC ownership variable is present here, and it's a dummy variable. So the variable dataset that I'm using is GPA1 from Wooldridge, which is available on Stream and also on Wooldridge's webpage. And we see that the college GPA increases for people who have who own a PC relative to the base group of non-owners of the PC. And if you own a PC, your GPA increases by 15 percentage points. So the college GPA, 15 points, 15 or 15.7. So college GPA variable is out of 4. So holding everything else constant or ceteris paribus, holding high school GPA and ACT scores or achievement test score constant, the fact that you own a PC is going to significantly increase your college GPA score. So nowadays this is something which is completely irrelevant because everybody owns a computer, and it's also kind of funny that they only refer to the PC as opposed to the PC and a Mac or whatever other computer system you use, but nevertheless that's what it is, the data. Okay, so the question is asking us in part 1 to add the variables MOTH call and FATH call and report the results in the usual form. What happens to the estimated coefficients or the estimated effect of the PC ownership? Is PC still statistically significant? So I'm just going to add 2 more variables, mother college dummy and father college dummy, and I'm going to actually name the original regression, and this will be a new one which will have a name COL equation 2. So we have added 2 variables to it. PC ownership remains significant, but it's a lot less significant than it was before. So the standard error is 0.06 approximately, and the coefficient has stayed unchanged more or less, and also the standard error. So it's slightly less significant than it was before. It's no longer significant at 1%, as you can see, but it's still significant. So the t statistic is around 2.58, highly significant. Now the next part is asking us to test for the joint significance for mother MOTH call and FATH call. Excuse me, I'll just pause it for a second. Okay, so to to report the f-test for joint significance, well, okay, first of all, the joint significance of these 2 coefficients is tested by an f-test. It basically is interpreted as a restriction that coefficient of mother college and father college are equal to each other and also equal to 0. So it's 2 restrictions. First of all, they are equal to each other. Secondly, they are equal to 0. And you can calculate this by writing an f-test and doing it the two different, so there are different ways to do this. The easiest one is obviously to run this test in Eviews, where you don't have to actually perform the regression with restrictions being imposed and the unrestricted and collect the R-squares. But it's important to know the number of restrictions. There are 2 of them here. And secondly, there's 1, 2, 3, 4, 5, 6 variables. So there's 6. The k minus 1 is equal to, k plus 1 is equal to 6, or k is equal to 5, and 141 variables. So it's 35 degrees of freedom. Excuse me, 135 degrees of freedom. So n minus k minus 1 is 135. Q is equal to 2. Right, so how do you actually perform it? First of all, note that both of these are insignificant individually. It's almost certain that they will be jointly also very insignificant. So their p-values are 0.95 and 0.5, very low t statistics, unless they would be somehow strongly correlated in a way that would make them jointly significant, but it's almost incomprehensible. So in Eviews, you go to coefficient diagnostics and Walsh tests. This is, although it's called Walsh test, it will perform all kinds of tests on coefficient values. The way you enter it in Eviews is you look at the coefficients on each of these variables. So actually what you can do is go to View and Estimation Output, View and Representations. And what you see is the estimation equation with the coefficients with a given number. So C1 for constant, C2 for coefficient on PC ownership, and so on. And so now it's easier to remember, or easier to write the coefficient diagnostics, the Walsh test. So what we're interested in, the C5 equals C6 equals 0. So you just type it in, C5 equals C6 equals 0, and you get 2 tests. The F test is the one that we're interested in. The F statistic is 0.24. There's 235 degrees of freedom, as I said earlier, and the p-value we're getting is 0.76, so we definitely cannot reject the null hypothesis. Of course, the null hypothesis is that it's spelled out here for you, so it's that C5 equals C6, so these 2 college dummies for mother and father jointly do not matter, and we cannot reject the null hypothesis. Okay, so going back to the results, does this make sense intuitively speaking? Well, it probably does make sense, because we are including variables that already are probably quite strongly correlated with whether or not mother and father went to college, with the presumption that if your mother and father go to college, they homeschool you possibly a little bit more intensely than if they don't, and as a result your high school GPA may already be higher, or your ACT score may be higher, or they may be more likely to buy you a computer to begin with. So this home, if you like, higher level of education at home, may have direct impact on these other variables that were initially included, so the additional impact is basically insignificant. So it's not that surprising. Okay, finally, a question asks, add the high school GPA squared. Alright, so HS GPA squared. Okay, and the coefficient is to 0.337. The t statistic is 1.56, and it's completely insignificant with 141 observations. So the high school GPA does not really matter squared in this regression. But what's more interesting is the actual high school GPA in level becomes negative. Now this of course implies that the relationship, and is also insignificant, the relationship becomes insignificant in a way that is a U-shaped form. So first decreasing and then increasing, and the turnaround point can be calculated as this divided by absolute value of this value divided by 2 of 0.33, so 1.8 divided by 2 divided by 0.337 is around 2.8. So it only becomes increasing after around 2.7, only becomes increasing after by 2.7 high school GPA, which is quite high. So it actually doesn't make sense, and you can think about it. Once you get these results that do not make sense after you add something that did make sense before you added it, It's probably a good reason not to add it, the variable. So you can think of it as more of a robustness check of the initial main finding. So I would definitely be excluding it, and I would also be excluding the mother and father college GPAs, which is basically this result here. The ACT score is also insignificant, and my guess is that it's also highly correlated with the high school GPA and PC ownership. You can actually do these kind of basic correlation checks by selecting all these variables you're interested in. So in this case, if you want to see how correlated is ACT with the other variables, you can just select them. ACT and high school GPA, and what was the other one? PC ownership. Open them, right click, open them as a group, and click view and covariance analysis and select correlation. You can select covariance as well, but correlation is enough. So correlation is particularly high between the high school GPA and ACT scores, which is probably why we're getting insignificance on the ACT scores, because all the effect is already going through the high school GPA. The PC ownership isn't that strongly correlated with either of them, but the correlation between high school GPA and ACT is quite strong. So maybe that's why, in any case, ACT alone would be excluded from the regression. Okay, so this is the first question. Let me see what else that we wanted to do. Okay, so the second exercise that we are going to go through is the exercise on C7.2, which uses data on wages and characteristics of people who earn them. Specifically uses their gender, uses their experience, education, hours they work, whether they're married or not, their race, how many siblings they have, whether they live in the south or the north of the US, how long have they been working at that job, and their age, to see whether what drives the wages. So the question asks to estimate the model where log of wage depends on the education, experience, tenure, marital status, race, so that's here just black and non-black, whether or not you live in the south of the US, and whether or not you live in the urban area. So that's what I wrote here. The file is wage2. Okay, so we estimated, this is what we get. We're supposed to report these results in the usual form, that's what you see, and the question is, holding other factors fixed, what is the approximate difference in monthly salary between blacks and non-blacks, and is it statistically significant? So left-hand side variable is in logs, so to compare, the gender dummy is black, so to compare blacks and non-blacks, you see that the difference in their wages is around 18.8%. The t-statistic is 5 and it's highly significant, so this is a substantial amount of difference in wages, conditional on everything else being the same. And what's interesting here, I think, which is quite useful to note, is that as you may know, southern US is has a higher proportion of black population, and controlling for south dummy in the regression allows you to deflect a criticism that might be arguing that the black dummy would be capturing the fact that the southern US have lower wages than the northern US, when in fact it's not the case, because if you include the southern dummy, we see that even after you condition for whether the person lives in the south or the north, there is still significant and large difference, 19% approximately, between wages of non-black and black. So obviously, if black is the dummy variable, non-black is the base group, so the additional wage is 18.8% lower for the black relative to the non-blacks, and it's highly significant. Second question is asking us to add variables experience squared and tenure squared and test whether they are jointly significant at 20% level of significance. So 20% is an unusual level, but we will do that. So adding experience squared, and what was the other one? And experience and tenure squared. Giving this a name. Okay, so those two variables individually are not significant, although this one is significant at 9%. The other one is insignificant at any usual level of significance. So, but you might wonder whether jointly they will be significant at 20%. Well, to test it again, as in the first case, 7.1, I would go to coefficient diagnostics and choose Walsh test. Oh, actually, before you do that, I would find out what the coefficients are. So representation is coefficient C9 and C10. Okay, so we want to jointly test the C9 and C10. So Walsh test, and we test also the restriction that are equal to 0. So there are two restrictions again, not only C9 equals C10, but also that they are insignificant, so they're jointly equal to 0. That's two restrictions. So 2 degrees of freedom on 952 degrees of freedom in an F-test. The value of the F statistic is 1.4898, so around 1.49, and it's insignificant. The p-value is 0.226, so even at 20%, this is not a significant rejection of the null hypothesis that they are both equal to 0, which is not terribly surprising. Both of them were initially very low in value, and neither was significant at 5%. So that's the second part. Third part is kind of related to our assignment a little bit. So it's saying extend the original model to allow the return to education to depend on race, and test whether the education does depend on race. So whether the return to education does depend on race. So the return to education is a partial, as you know from lectures, and we've done this in lab as well, I think, is a partial derivative of the log wage, or how much does the wage increase in percent when education rises by 1 year. So without anything else in our regression, I'm going to exclude these two squares because they are both insignificant. But without anything else in our regression, so this is actually just equation 1, I can delete equation 2. So with nothing else in our regression, a return to education is around 6.5%, right? 6.5%. So it's a partial derivative of log of wage with respect to education. It's just that coefficient. If I want to make it this partial derivative, or the return, in other words, depend on race, I have to also add an interaction dummy of education times race dummy times black. So I'll add that. Actually, I'll put it right behind education so it's easier to read. Education times black. So this additional dummy variable has a coefficient around minus 0.226 and is not significant. The t-statistic is minus 1.12, and so the p-value is well 26%, so it's completely insignificant. So first of all, we can say if we take the coefficient literally, we see that the return to education is around 2% or 2.2% or 2.3% actually lower for black men than it is for non-black men. Okay, so now this education is only for for males. All right, so 2.3% is a substantial amount, but unfortunately it's not significantly different from 0, so it's not clear whether this is actually whether the number is actually significant or not. But the number itself, the point estimate, is definitely non-trivial. So it's not. Although, so how would you describe this? You would say, well, it's a non-significant difference in the return to education. Remember, this is not overall difference in wages. This is difference to return to studying 1 extra year. The difference is definitely large. However, it's not significantly different from 0. So the precision is quite large. In fact, you could test for heteroscedasticity or some adjustment. If you find heteroscedasticity, maybe you can apply an adjustment and this will become significant, but it's so far away from 5% that I kind of doubt it. Right, and the last part, so this was the part 3, and the last part is asking us to start with the original model, but now allow wages to differ across 4 groups of people. Okay, so the four groups of people are going to be married and black, married and non-black, single and black, and single and non-black. And then the question is, what is the estimated wage differential between married blacks and married non-blacks? All right, so just like in lecture, we have four groups here, and so we want to somehow split it in, so we cannot include all four because the four would add up, the values of the coefficient, the values of the dummy variables would be exactly equal to the constant vector of ones, and therefore they would be perfectly collinear, violating one of the assumptions of the OLS. So you basically couldn't estimate it. So in order to do that, to estimate it, you need to choose a base group. So what we're going to do is choose a single non-black group as the base group. And so then we can add dummies for everything else. So dummy for single black, married black, and married non-black. Okay, so I'm going to just add these into the regression. Which I'll create a new one, so I'll leave this as it is, and I'm just going to add interaction. You could create new variables first, it might be easier, but anyway, married times black, but you can just type it in directly, like I am doing now. Single times black, oops, and married times black. No, single is not defined. What was it? What was it? Siblings. Oh, single is just not married. So, right? Yeah. Okay. Sorry. So married times black. 1 minus married times black. Okay, this is interesting. Okay, married. Oh, married and black. Sorry, I have black all three. So that should have been married non-black. So I'm okay. So including married black twice. Obviously stupid. 1 minus black. So I wanted married and non-black. Okay. This second part is single and black and married and black. So then the base is single non-black. All right. So this should work. What still? What am I doing wrong here? Married non-black. Yeah. Single. So 1 minus married and black. And oh, right. Silly. So I'm also, so I forgot to take these out. So of course, you know, I'm also including black and married in there, and I have married here, and I've married here, and I have married here, so those are collinear. So I need to take those out. So I'm basically splitting the married and black into subcomponents, and that is the interaction of them basically. So married and black is going to be separate from married and non-black, and married single and black is going to be separate from single and non-black. Okay, so now it should work finally. Thank you. All right, so I'll give it a name, equation 2. All right, because, well, I can put it on the left, I suppose. And on the right we have the new results. Okay, so the R squared is 0.25 approximately, and the number of observations 935. Now these interaction terms are positive, negative, positive. The last one is insignificant, and they're all relative to the base group, which is single non-black. Okay, so everything else being the same, being married and non-black gives you around 18% higher return than, or 19% higher return than, or higher wage, I should say, than being the base group. So married single non-black. So this is basically for the non-black person a return on marriage, if you like, in terms of salary. Everything else being the same. If you are a single and black person compared to the single and non-black person, then your salary is actually 24% lower, which is very large and significant at 5%. And finally, if you are a married and black person, to compare this to the single non-black person, your salary is just marginally higher, around 1%, but it's not significantly different. Okay, so those are quite, strong results actually. And anyway, the question that was being asked was, what is the estimated wage differential between married blacks and married non-blacks? Okay, so married blacks and married non-blacks is the gap between 0.094, well, 0.0094 and 0.189 approximately. So it's a negative of 1.8 almost, 1.79 or something. Let's say minus 0.18. So a married black man earns about 18% less than married non-black man. Of course, here I constructed by comparing these two coefficients. But you could alternatively do the same thing if you chose one of these two as the base category. So if I choose married black man as a base category, then the coefficient on the married non-black man would be approximately 18, 0.18, 179. So, and if I did it the other way, that I chose the married non-black male as base category, then the coefficient on married black male would be negative minus 0.179 or 0.18, 18% low. So you can calculate that effect from either of those regressions. The easiest way would be to choose one of them as the base. So let me just do it here quickly, because that way you could easily calculate whether it's significant, right? So, but of course, in here I could do the same. I could perform that same calculation of significance. I would first want to see the representation so I know which coefficients I'm looking at. So C7 and C9. So the question is it significantly different? Are these two coefficients significantly different? And so I would go to coefficient restrictions, and as usual now, C7 equals C9. Oops, equals no, that's the only restriction actually. And I can strongly reject it, which is not really surprising, because even though one of them is basically insignificantly different from 0, the other one is very highly significant. So we can reject the fact that the two, or the hypothesis I should say, that the two are the same. So the difference between them is clearly very large, even though one of them is insignificant, but its point value is anyway 0. So the difference between them is clearly going to be significant, and we have concluded that. Now, as to the economic value, this is a very large gap, obviously, because both of these people are married. One has a different gender, and we are already controlling for their education, experience, and tenure, and whether they live in the South and whether they live in the urban or non-urban area, and the gap is still 18 or 19%, or 18% basically, so very large. And I think that's kind of going to cut it for this recording, because I guess if we had some discussion time, then that would cover 50 minutes. But let me see, I'll have a look a little bit through the textbook if we can do another one. And if not, then that covers everything for this missed estimation, missed econometrics lab. Okay, I think that's enough. I mean, there are lots of other exercises you can see, and one of these is actually in the assignment, as you can probably figure out. But anyway, these are not terribly different from each other. If you have specific questions to one of those 14 exercises, just computer exercises, just send me an email, and I can let you know what I can help to diagnose your problem and sort of help you with the answer to that problem. But for now, I think this is perfectly sufficient. So, okay, I'll try to upload it, and I'll post a note about that uploaded video to Stream. Bye.